In this video, I want to talk about transcription initiation in eukaryotes. Now, in this one specifically, we're going to do it for mRNA. So it's the initiation of mRNA transcription in eukaryotes. And I wrote here, beware, silliness ahead. I might say some silly things in this video. So I apologize in advance if that's off-putting to anybody. Okay, so the first thing that's going to happen is that if we have DNA, DNA has the Tata box in the promoter region of eukaryotes. So the first thing that's going to happen is transcription factor 2D is going to bind the Tata box. Now, how can it do that? Transcription factor 2D contains this thing TBP. Now, TBP is this thing called the Tata binding protein. So that Tata binding protein is what allows transcription factor 2D to actually bind the Tata box. Upon binding the Tata box, the transcription factor 2D, after it binds, it recruits RNA polymerase II along with some transcription factors with it to the Tata box and this region here. So RNA polymerase and transcription factors to H, E, F, A, and B all join to form this thing called the pre-initiation complex. It's also known as the basal complex. So how do you remember these details? Well, the way I remember it is, well, it's transcription factors to H, E, F, A, and B, and they're coming in with RNA polymerase II. Well, for me, it's not too difficult to understand that RNA polymerase II is going to come in because I already know that I'm talking about mRNA transcription. But the way I think about, or the way I remember which transcription factors come in, is we're about to start a party. We're about to transcribe some mRNA. Party time. So he fab joins the party. He's fabulous and he's ready to party. Okay? So that might be a little silly to some of you, but that's the way I remember about which transcription factors are coming here. Okay? Now, that pre-initiation complex, what that allows for, it basically stabilizes the helix and begins to open it up and get it ready for transcription. So this here is now the open complex that I want to note here. The open complex. Once that complex is stabilized and open and ready to go, H, B, and E, those three transcription factors leave. Transcription factors to H, B, and E leave the complex. So how do I remember that? The way I remember that is, oops, I want to get rid of that orange there. So after joining the party and opening things up, he decides he no longer wants to stay. So he be exiting. He leaves. H, B, and E leave. Okay? Here H, E, F, A, and B join the party. Now H, B, and E, he be exiting. They all leave the party. Okay? So RNA polymerase II then, its CTD, or carboxy terminal domain, is phosphorylated. So what is the carboxy terminal domain? Well, RNA polymerase is a protein, and proteins are made up of long strings of amino acids. Amino acid chains, polypeptide chains, have amino termini or an amino terminus rather, and a carboxy terminus. So its carboxy terminal domain is phosphorylated. Once that happens, transcription is initiated. It can go. So transcription begins. So then what happens? So transcription factor two transcription factors, D and A, stay at the Tata box. So the way I remember that is, this might be a little bit silly, but I think, "Da, you stay here," like in a sort of Arnold Schwarzenegger voice. I just think of the Terminator when I think about this step here. Again, super silly, but if that helps me remember, hopefully that silly joke helps you too. So transcription factors 2D and A both stay at the Tata box. Then RNA polymerase II, along with the only transcription factor left here, other than these two and the ones that left, is F. RNA polymerase II and transcription factor 2F continue synthesis until a termination site is reached. So they're synthesizing the mRNA, and they're going to keep going until a termination site is reached, at which point the RNA polymerase II will fall off. And that's pretty much it as far as initiation of transcription of mRNA in eukaryotes. I apologize for anyone who didn't like the silliness, but if you did like it, I'm happy about that, and happy studying. Hope that video was helpful. One last thing, I'm a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com. See the description below for more details. Thank you for watching and putting up with my silliness.